The main job of filtering out contaminants is done by the inline filter. This filter traps and collects even smaller particles, as small as 10 to 20 microns. A micron is around 1/25,000th of an inch. That means they're so small you can't even see them with the naked eye. Small particles of rust and other contaminants can damage finely machined injectors and other fuel system components. Just like an air filter, this inline fuel filter collects contaminants and will eventually clog. That's why you need to replace it at regular maintenance intervals. Clogged filters force fuel pumps to work harder, reducing the fuel available to power the engine and limiting the fuel needed to cool and lubricate the pump. A fuel pump that's starved for fuel requires more energy and can blow fuses. Now, replacing the right fuse with a bigger fuse, that's just a Band-Aid. If you keep blowing fuses in that same place, know that you probably got a sign of other electrical problems. A properly functioning fuel pump delivers more pressure and volume than the engine needs. Unless your daily driver is one of these. Fuel not needed by the engine is returned back to the tank. This continuous supply and return of fuel aids in cooling the fuel as well as the pump. Mounted on the fuel rail, the fuel pressure regulator controls fuel system pressure according to the engine's demand for fuel. Fuel pressing against the pressure regulator diaphragm compresses the spring and opens the valve, allowing excess fuel back to the tank. A vacuum line connects the spring chamber of the pressure regulator to the intake manifold. Changes in engine vacuum vary fuel system pressure according to engine load. Fuel system pressure is constantly maintained by this unique, calibrated spring diaphragm relationship. Actual system fuel pressure and volume depend on engine size and load requirements. On most non-return type fuel delivery systems, the fuel pressure regulator is mounted on the fuel pump module, eliminating the need for a separate fuel return line. Excess fuel is bled off directly from the pump into the tank, and on some vehicles, the computer also helps raise and lower the fuel pressure. So, what turns the fuel pump on and off? In this circuit, turning the key on sets a whole series of events into motion. A signal from the power control module, the vehicle's computer, closes a contact in the fuel pump relay which switches the pump on. Some vehicles have an inertia switch which must be closed for the pump to run. A jolt or an accident may open the switch and keep the pump from running. You'll have to manually reset the switch to start the vehicle. Turning the key off turns off the signal from the vehicle's computer. The loss of electromagnetic force releases and opens the contact, turning the pump off. For all of the specific details about a vehicle's fuel delivery circuitry, refer to the service or repair manual for that vehicle.